Hello, grade 9, this is Mr. Hunter, and I'm going to do a little podcast to hopefully help you with your grade 9 test on bonding. And when you're looking at this grade 9 test, I think there's possibly 4 main areas for you to study: ionic bonding, covalent bonding, modes of molecules and compounds, and the properties of all structures, that is, the properties of ionic, covalent structures, and that would also mean looking at whether things are giant covalent or giant ionic, or simply simple covalent or molecular. Okay? So the first thing we're going to look at is ionic bonding. You should be fairly familiar with this. A couple of examples and how you would be asked to write them out. So, for example, sodium chloride. How do we show the ionic bonding in sodium chloride? Well, in sodium chloride, sodium, electronic structure 281, coming from the fact that it is atomic number 11. 1 electron in its valence shell. Chlorine, 7 electrons in its valence shell. Okay, sodium is going to lose that 1 electron. Chlorine is going to gain that 1 electron. And you're going to get sodium, having lost an electron, it's got a new shell of 2, 8. And chlorine is now 8 electrons in its outer shell with an additional 1 from the sodium. So it's 2, 8, 8. I failed to tell you, of course, that chlorine was only 287. That comes from the fact that chlorine has 17 outer electrons, because it's got atomic number 17. The charge on sodium, well, sodium has lost an electron. It was neutral. It lost an electron, which is a -1 charge. It now has a +1 overall charge. Chlorine was neutral. Gained a -1 charge, it has a -1 charge. Don't forget to put in the charges. Now we're going to come back to look at the charges on ionic compounds when we look at the simple structure of sodium chloride. And you need to know that simple structure of sodium chloride. But you can obviously see that the attraction between the positive and negative ions is the, as it were, the ionic attraction or the ionic bond. Let's have another look at a different example. Here would be calcium oxide. Now note that calcium oxide is 1 calcium and 1 oxygen. And that comes from the fact that, well, remember we looked at formula, calcium +2, oxygen -2. Hey, they cancel out, right? 1 + 2 cancels out another -2. So you get CaO. The real reason for that is that calcium is in group 2, so it has 2 valence electrons. Its structure is 2, 8, 8, 2. Oxygen is in group 6. It has 6 valence electrons. It's 2, 6. Calcium donates, or I should say transfers, both of its electrons to the oxygen, giving calcium an electronic structure of 2, 8, 8. 8 electrons in its outer shell, but it's lost that first 2 shell electrons. It's got a charge of +2. Oxygen has gained 2 electrons, both from calcium. And it's got a charge of -2. Its new electron configuration is 2, 8. Now, what's interesting to note here is that, again, the ionic attraction is between the +2 and the -2, but that's twice as much as it was for the sodium and the chlorine. And that is the reason why calcium oxide has a much higher melting point than sodium chloride. The +2 and the -2 attract each other more. Okay? One more example of ionic bonding. If I can get the board to work. There we go. Let's see, magnesium chloride. Now magnesium is in group 2, so last topic we looked at the formula. Well, that would be +2 and this is -1. Okay, cross them over. MgCl2. Okay. Sorry, that was in this topic. So we get MgCl2. Now, how does that come about? Well, magnesium is in group 2. 2, 8, 2. So it's got 2 outer electrons. Chlorine is group 7. 2. You can give away 1 electron to 1 chlorine, but you need to give away another one to this one here. Giving you magnesium, got 8 electrons in its outer shell, 2, 8. Notice I didn't add 8 electrons there. This is this existing shell. I'm just showing the new valence or outer shell there. You see that? And the chlorines, well, they've all got 7 electrons. Charge 2+ for chlorine and 2 minus charges for the chloride, and 2+ for magnesium. Notice that the charges cancel out, which is of course consistent with the formula model that we looked at before. Remember we did the form a block game, or the idea that you get 2 minuses cancelling out the 2 pluses. Okay, I'm going to stop now. That's a little examples of ionic bonding, and I'll do some other podcasts for covalent bonding, formula and structural stuff later on. Tschüss!